9 steps that we need to follow throughout these 2 hours class, from step 1, create the drawer, until step 9, which is the MCQ. MCQ is basically to test out how well we understand this chapter after 2 hours, right? Yunjie has already done this, Jaden has already done this, and usually the result is good. As long as you promise yourself these 2 hours, you do not distract yourself intentionally by checking your WhatsApp message, checking your TikTok these applications, or even using your brain to start thinking about later what you are going to have for lunch, for breakfast, or tomorrow what you're going to do, right? So just promise yourself and promise me for these 2 hours, focus as much as you can and follow the step that I'm going to tell you as much as you can. And I promise you, by the end of the 2 hours journey, you will be able to understand quite well this chapter, right? Give me a few seconds. I just need to go and check out Han. Right, I'm sorry. Okay, so yes. Also, I have to tell everyone that I'm not a physics teacher. My job is not teaching students about physics, but I like to read. I like to study. So I created a study method, and with now the AI technology, I'm able to reduce the time that is needed to study the entire chapter from usually 2 weeks to 2 hours. So what I'm doing right now is to share you the study method using electricity and electromagnetism as the content, right? And using this method, I've been getting quite good results for the past, many years when I was taking my exams. That's why I'm able to get into one of the Malaysia top university and top courses. So just to give you a confident level that what we are engaging in is something proven by me, and I hope that I can teach you the experience that I've gone through, and hope that this study method is also going to work for you. Right, is that clear? This class will be quite a lot of interactions, as Jaden and Yunjie know. So be on your toe, that I will be asking questions about the content of the chapter that we are going to learn. All right, Natalie and also Eric, are you ready?
Yes.
Okay.
Yeah.
Good. So we start at 9:08. Then let's see what time we end later. It's about 2 hours. So the first step is to create drawer. What do I mean by create the drawer? In this chapter, I divided the chapter into 4 drawers. Let me pull out the 4 drawers. Just give me a second. Okay, we can see from here. So there are 4 drawers over here. No, 5 drawers for this case. For this chapter, we have 5 drawers. Electric charge, current, voltage, and resistance, series and parallel circuits, magnetism, and electromagnetism. I think it's better for me to just pull it out and attach it to the same notes. Okay, just need to format it a bit. Okay, it's fine. So the first step is to create the drawer and to remember the drawers. There are 5 drawers, and the name of drawer is as shown over here, right? And how are we able to remember the drawer easily? We have done this method before. You're using emotional stories to be able to help you to remember the name of the drawers easily. So for step 1, is just remembering the name of the drawers. Nothing more than that. You do not need to worry about what is the meaning of electromagnetism. You don't need to worry about the current, voltage, and resistance. At this point, step 1, remember the name of the drawer in sequence. Right. So I will repeat again. Electric charge, current, voltage, resistance, series and parallel circuits, magnetism, and electromagnetism. Right. So what is the story that I created? This story can be any story. This story is something that I created out of random thinking and trying to associate um, with some emotions that is either silly or funny to help us to be able to remember this easily. Right. So let me just format it first, because when I copy it, the format is out, especially on the bold alphabets. Right. So far, I think everyone is following and understand what we are going to do next, right? If not, just raise your hand. I think everyone knows everyone here, so you don't need to be shy, right? So the story that I try to create for everyone here to remember these drawers in sequence easily is I use Elise charge Cristiano Ronaldo EV car, right, in Silly Park, in the park called Silly Park, right? Using what? Using magnet, and got electrocuted. To make it more emotional, I think Yunjie and Natalie, you can imagine your best friend, Elise. She was charging her idols, her friend, her best friend, or Cristiano Ronaldo. And the EV car of that Ronaldo obviously is something very sporty and something very expensive. Okay, and where did she charge the car? She charged it in a silly park. And how she charged it? She sillily used magnet to charge it and got electrocuted. So you can imagine that she got electrocuted, and the the hair was messed up, and her face was burned. Right. So I'm trying to trigger emotions. I'm trying to trigger emotion that can either funny emotions, or whether it's something that is very silly, so that you'll be able to remember this easily, right? So Yunjie, can you repeat what is the story?
Elise charges CR7 EV car in Silly Park using magnet and got electrocuted.
Right. So you can input that story inside to create that story into the picture of inside your brain, and you can imagine the story, how it looks like. Why Elise? Because the first drawer is electric charge. Okay, so Elise charges. So it's talking about the electric charge. For you to remember the first drawer, the name of the first drawer. Don't need to worry about the content of the first drawer now, but the name of the first drawer. Cristiano Ronaldo EV car, right? C is current, R is resistance. Then the V is voltage. Okay, Cristiano Ronaldo, which is in a short name, is CR7 EV car, right? EV is also related to battery, also related to electricity, so it fit well, I think. In where Silly Park is series and parallel circuits, right? Using magnet. So the magnet represent the magnetism, and got electrocuted. So electromagnetism, I took out the electro and I replaced it as electrocuted to create that story. Right. So now I believe it's quite easy for everyone to remember the drawer in sequence now. Elise charges an EV car, Whose EV car? CR7 EV car. Where did it happen? Happened in a silly park. And how did she charge it? She charged it using magnet. She should not be using magnet. Magnet cannot charge a EV car, but she sillily used a big magnet or a pink magnet or whatever magnet that can help you to remember this magnet. And unfortunately, she got electrocuted. Right. Okay. So this is step one. Step one. We created the drawer and remember the drawer. Now, continue to step 2, 3, 4, and 5. This requires quite intense reading. Right. This is the most difficult part of the entire brain drawer method. The whole step 1 until 9, we call it brain drawer method. Right. I intentionally put the reading part as the initial part of our learning steps because this is the hardest part. Okay, but I need you to help yourself and myself to focus and be committed for these 2 hours. Right. This part maybe will take about 1 hour or a little bit more. It requires you to read. Right. So let's go to step number 2. Read the keynotes. What is the keynotes? The keynote is here, right in front of us. Here. Step 2, read keynotes from here, electric charge, until the relay. If you realize, the format that I've created for these keynotes is similar to the drawers. We have 5 drawers, right? So you can see the first drawer is electric charge. Second drawer is talking about the current, voltage, and resistance, which is the Cristiano Ronaldo. The third drawer is the series and parallel circuits, which is in the silly part. The fourth is the magnet. The fifth is the electromagnetism, which is at least got electrocuted. Right. Now, I added a bit more informations in each drawer. Right. So what you need to do now is just to read. If you can understand what it means, what's the meaning of this, it's fine. It's good. If you do not understand, it's also fine. Don't worry. We are still in step 2. What you need to know is just to get yourself warm up on the terms, on the new terms, if it is new to you, in each drawer, right? So for example, I'll start electric charge and static electricity. Okay, forget about the part that is in the column, in the bracket for now. Just skip it and go to the next, right? Every drawer will have this bracket. Yeah, we're going to use this bracket later. So electric charge and static electricity. Atom has protons, electrons, and neutrons, right? So if proton, electron, and neutron is a new terms for you, it's good. Don't worry. Just warm yourself up that there is something called proton, electron, neutrons that you have to learn. You'll be learning later, right? Then there is repulsion and there is attractions. If you don't understand why repulsion and why attraction, it's fine. This is normal because we are still in step 2. You just need to know that there is something related to repulsion and attractions that you will be learning in the further steps, step 3, 4, 5, and so on. Then you have electron transfer, right? Same thing. Don't worry. If you don't understand, you just need to know that there is something about electron transfer. And that's it. That is drawer number 1. That is drawer number 1. That you have 3 key notes or key points that you need to warm yourself up now before we are going into more information or understanding related to this drawer number 1. Okay, I hope it's clear, especially for Natalie and also Eric, because this is the first time you attend this class. So I hope that you are able to follow the steps. Right. after the step, the drawer number 1, which is the electric charge, which is release charges, right? Then the next one, the second drawer. What is the second drawer? Jaden, can you tell me what is the second drawer?
The second drawer is electric circuits.
Jaden, you have to speak louder.
Electric circuits.
Electric circuits. Electric circuits is the second drawer, yes. The name of the second drawer is current, voltage, and resistance, right? And the story that is associated to this current, voltage, and resistance is CR7 EV car, all right? CR7 EV car. I think Natalie and Eric, you'll be thinking, why am I keep repeating myself on points related to the drawers? And why do I ask very obvious questions? Like I'm asking Jaden, what is the second drawer? And I bold it. I did it intentionally. Well, because the point here is not to test whether you are able to remember this 100% now. The point here is to get you practice and get used to the name of the drawers and the story. So by having everyone to repeat it a few times, these stories will get easier for you to remember, and the name of the drawer will get you easier to remember, right? So for the second drawer, you can read by yourself, right? Read by yourself. And then you, like I say, if you do not understand, don't worry. You just need to get yourself warm up on the new terms or new informations that you are going to learn in the next following steps, right? So I'll give you 1 minute to read here from this second drawer. Let's start now. If you have finished reading, you can read it again and again and again for within this 1 minute. All right. So that is the 1 minute that we have allocated to read drawer number 2, right? Now, drawer number 3. Let's start with Eric. Eric, can you tell me what's the drawer name?
The drawer name is series and parallel circuits.
Yes. Which part of the story is associated with the drawer number 3?
The silly park.
Yes, the silly part. The S for the series and the P for the parallel, right? So I'll give you another 1 minute to read this. This is a bit new to, I think, the student who haven't studied this chapter. But don't worry, like I said, just warm up yourself with the terms that you need to learn a bit later. So let's read this. All right. Now, let me give you some hint. Yeah, but before that, I think with this pace, we are going to exceed 11 o'clock. So maybe we're going to end at 11:30. Is that fine for everyone? Inje is fine. Eric, is it fine? Okay, I think it's fine for Jaden, and I believe it's fine for Natalie. But in any case, if you are not fine and you have to leave, it's fine. You just tell me that you have to leave, then we will excuse you. No problem. Right. So a hint over here. How do you read such informations? Right. This small little paragraph. There are two categories. The name itself is telling you that there are two categories for the circuits. You have the series and you have the parallel. And then within the series, of course, you have the definitions. Then after the definition, you have some descriptions about how the current and voltage and resistance would react or would act in a series circuit. Same goes to parallel. It's also current, voltage, and resistance, right? So you see, it is a bit related to the previous chapter, previous drawer, which is the drawer number 2. And drawer number 2 is explaining what is these circuits, current, voltage, and resistance. And then you break it down into two categories, the series circuits and the parallel circuits, how current, voltage, resistance is linked to these circuits, right? Again, don't worry if you do not understand now. You will understand it more later, right? So Natalie, your turn. Tell me the name of the fourth drawer.
Magnetism and Earth's magnetic field.
Right, magnetism and Earth magnetic field. And tell me which part in the story is related to the fourth drawer.
Magnet.
The magnet, right? Elise choose to use magnet to charge Cristiano Ronaldo expensive EV car, right? Which is a wrong choice. Okay, that's it. So let's continue on this part. I think this is less than 1 minute. Let's do 30 seconds. All right, 30 seconds, I think is enough for you to read these 3 lines, short lines. Right, so obviously this magnetism and Earth magnetic field is related to the Earth magnet. We are going to learn about the North Pole and the South Pole for the Earth. So let's go to the fifth drawer. Fifth drawer. I think let's get Yunjie to tell me what is the name of the fifth drawer and how is it related to the story.
Electromagnetism and its applications.
Yes, which part of the story is related to this?
Electrocuted.
Who got electrocuted?
Elise.
Are you happy to know that?
Yeah.
Okay. All right. So you can imagine Ellie's hair was very messy and burned with smokes, and her face was all black, right? So I'm trying to trigger emotions. This emotion is a funny and silly emotions, right? Luckily, Elise is not here. All right, so let's read this. Let's take 1 minute to read this. All right, so now we have done step 2. So far, with this very slow pace, we took about 20 minutes. 20 minutes to complete step 1 and step 2. Usually, this can be done in 10 minutes, but it's fine. 20 minutes is just another 10 minutes from the original 10 minutes, right? 10 minutes it's not too long, as long as everyone understand these first 2 steps well. Now, let's do a recap. And I need Jaden. Jaden, can you tell me the story again? The story.
So Elise charged the CR7 EV car in a silly park using magnet and got electrocuted.
Right. Okay. So I think by now everyone can easily or easier to remember the 5 drawers in sequence, right? Not just remember it randomly, but in sequence, right? So Elise charges represent the electric charge. CR7 EV car represent the C is current, R is resistance, V is voltage. In where? In a silly part. And that silly part represents the series and parallel circuits. Using what? Using magnet, because it's silly to use a magnet to charge EV car, right? So using magnet. So drawer number 4 is magnet. And unfortunately, she got electrocuted, right? Whether using magnet to charge EV car can get you electrocuted, I do not know. I don't think so. But for this case, for the silly story, she got electrocuted because we want to have some very silly picture that we can picture in our mind that Elise got electrocuted with the messy hair and black face, right? Electrocuted represents the electromagnetism, okay? Now, let's go to a bit more heavy on reading the summary. Right, we're going to do the same way. How do we read the summary? I'm going to give you some time to read. And what is the technique of reading it? Let me just pull it out. Oh, techniques. Let me just give me a second. Techniques. Yep. Put this back. Okay. This is the technique how you read. How do you go? How do you read a summary of step 3? I think I haven't explained to you what is trainable skill number 3 for Natalie and also Eric, but it's fine. You can continue on the steps. When you have to read this step 3, what do? You read the notes. What is the notes? The note is on your left hand side, which is this part here. This part here. Then after that, what do? You identify whether this note is related to which drawer. You have 5 drawers. You tell me which drawer. it belongs to, right? Then you ask yourself while reading this part, for example, ask yourself if there is new information or new understanding that you get from reading this, comparing to the keynotes that you have read just now, right? So obviously, for this case, you have more information in the notes comparing to the keynotes that you read in step 2. So if you identify this new information, keep it and put it inside your brain. All right? Okay, let's practice one time, then I think you can understand it better. Now, I'll go with you on these steps so you understand what I told you just now, right? So for the first one, reading summary. Drawer 1, electric charge and static electricity. So let's read this together, right? I'll read it out loud. Fundamentals of electric charge. Atomic structure and charge. Electric charge is a fundamental property of matter, originating from the particles within atoms. Atoms are composed of 3 smaller particles. Protons possesses a positive charge, electrons possesses a negative charge, neutrons possesses no charge, which is neutral. An atom is considered neutral because it contains an equal number of protons and electrons, causing their charges to cancel each other out, right? So usually I'll give you about 1 minute to read this. And when you're reading this, these are techniques. You tell yourself, which drawer is this? This is very obvious because it's already stated over here. Is drawer number 1. And drawer number 1 is electric charge. That's the name of the drawer. Then what you do is, while you're reading this, you compare it with drawer number 1 in the keynotes. Right. Drawer number 1 in the keynote is just these 4 rows. Is there any new information comparing to these 4 rows? Obviously there is, right? It's talking about the protons, neutrons, and proton, electron, and neutrons, which is mentioned here. So it's not a new information, but it's talking about proton is positive charge, electron is negative charge, neutron is no charge. So this is new information that is not appearing in the keynotes, but is in the summary. Then also it's talking about the atom is neutral because why? Because the number of protons and electrons are the same. So the charges cancel out each other. So those are the new informations. So those new information, I need you to intentionally take it out and put it inside your own drawer. Okay. So now you have 5 drawers, and you have to create your own virtual drawer inside your brain. All right. So let's try the second one. All right. I'll repeat the second one with the same. I'll read it out loud. Then we'll continue the third and so on by yourself. Electrostatic interactions. Charged object exert non-contact forces on one another, resulting in either attractions or repulsion. So what is attraction? What is repulsion? Repulsion occurs between objects like charges. A positively charged object repels another positively charged object. A negatively charged object repels another negatively charged object. Attractions occurs between objects with opposite charges. So positive object attracts to negative charged object. So if you can see, this is related to drawer number 1. And which sub-drawer? Obviously, it is the second one, right? So now I think you can realize that it is coming in sequence. So the next one is going to talk about the electron transfer. And then the next one is going to talk about drawer number 2 and so on and so forth. Right. So this is how you read it. So this is what I call framework thinking. Right. But forget about framework thinking for now, because I think this is is a bit advanced for you to understand, but just follow the steps. Just follow the steps. It will make you easy to relate. Okay. Natalie and Eric, is it clear on what you need to do?
Yes.
Right. Okay. Okay. So now you already know what is repulsion, and now you already know what is attractions, right? Repulsion is when you are having the same charges, positive and positive, then you will repels. Negative, negative, it repels. If it's positive and negative, then it will attract. Okay. Now let's do this by giving you 1 minute. Let's start now. Oops, sorry. Okay, let's do a very quick questions. Natalie, can you tell me which drawer is this?
The first one.
Drawer what? Drawer
The
one?
first drawer. Yeah.
Yeah, the first drawer, yes. Okay, good. So this is the first drawer and it's related to the electron transfer. All right. So I believe you have already read this, and obviously there are new informations that is in this small paragraph compared to these two words, right? So you need to have this skill to extract or identify the new information that is over here compared to what is, yes, your reference for in the keynotes. All right. Let's go to drawer two. Drawer two. Let's start for this. You can read now. Let's do 1 minute. All right, 1 minute is done. If you are worried about you are not able to fully understand these 4 points, don't worry. It is normal. If you can fully understand these 4 points at this point of this time, then you're a genius, right? You're something. So you're a very, very good student, right? But not most of the student, you do not fully understand this at this point, right? Like I say, at this point, you just need to warm up yourself to know that there are these new terms like current for this case, and what is inside the current, right? So you know there is this definition about the current, which is amount of charges flowing per second, right? Charges is what? Charges is the electron, right? The one that we learned on the first drawer. Then you need to know a bit of the mechanism, how this is done. right? So the charges particle that move free electrons. And these free electrons is the movement of free electrons is the current. The faster the movement, the higher the current. And what is the measurement? The measurement of current is amperes. So 1 ampere is higher than 0.1 ampere. Right? 10 ampere is higher than 1 ampere. Right? And the symbol is A. And how do you measure current? You use ammeter. You use ammeter, right? So yeah, this is the same example that I explained just now. Then how can you measure it? You have to have this complete closed circuit, right? If there is an open circuit, then you are unable to measure the current, right? So these are the few very simple informations that is new to you compared to what you have read in step 2, right? Step 3 has more information than step 2, obviously, right? Else then it will not be step 3. Okay. Now let's go to the next one, right? If you realize the sequence is the arrangement is in sequence. Now we are going to voltage, and we are still in drawer number 2. Okay, let's start now. Okay. Eric, which drawer are we in now?
Drawer 2.
All right. What is the name of the drawer?
Potential difference.
Drawer. Okay, that is a sub drawer. You're right. Sub drawer is voltage or potential difference. The drawer is current, voltage, and resistance. Drawer number 2. Right? And the story that is related to drawer number 2 is Cristiano Ronaldo EV car. Okay. And for this particular part is the EV of the V in the EV. Right? So let's do this, the same steps or same techniques, 1 minute. Okay, let's do the next one. You get 1 minute as well. All right, let me do a small explanation about this. This you can see if you are related, if you are link it to step 2 is V equivalent to IR. This is a formula. So voltage is the V, I is the current, R is the resistance. So if the voltage is the same and the current is increased, that means the resistance need to be decreased, right? If the voltage is the same, the current is decreased, the resistance will increase. This is like a multiplications formula equations, right? I think and also you can calculate the R by moving the I on the opposite side of this equation. So V divided by I equivalent to the R, which is the resistance. Right. Next, drawer number 3. Okay, let's continue on this. And by the way, if like I say, if you do not have 100% understanding of what you have read just now, it is fine. You don't need to know 100% at this point. You just need to know more than what you understood when you were in step 2, which is about 10 minutes ago, right? If 10 minutes now, which let's say the Yunjie of now, 10 minutes later, is getting more understanding about electrical resistance comparing to Yunjie 10 minutes ago, and that is already a success. Okay? Now let's continue on this. Now we have moved to drawer number 3. Let's take 1 minute.
Uncle Alan，我可以去厕所吗？
Okay. Okay, let's do a toilet break for 3 minutes. Then we start this again. Okay, let's come back in 2 minutes. 20 minutes, 20 seconds. Okay, let's continue. Let's close this. Let's continue here. Start now. Okay. Just to make sure, can I have a show of hand? How many? Is everyone back? Inje is back. Natalie is back. Eric is back. Jaden. Or you can just.
Yeah.
Yep. Okay. Good. So everyone completed series circuits and parallel circuits, right? And like I say, don't worry if you do not fully understand. You just need to pick up the new informations that you pick up while reading this as you compare to this, right? So the 10 minutes ago, Jaden, and the 10 minutes now, Jaden, 10 minutes now, Jaden know a bit more information than 10 minutes ago, Jaden. And that is what we are trying to achieve now. We're not trying to achieve 100% Jaden who knows 100% of what is written over here. Okay. Okay, let's do this. Now we move to which drawer? Natalie, can you tell me which drawer?
The fourth drawer.
The fourth drawer. Are you okay? It sounds like you just wake
Yeah.
up. Okay. All right. Let's start 1 minute. Okay. So this is the drawer that Elise sillily took magnet and tried to charge the expensive Cristiano Ronaldo EV car. All right. There's one small part for the fourth drawer. Let's start now. All right, earth magnet. Fifth drawer. So this is the part our good friend Elise got electrocuted. Let's start now. Okay, I think this part is getting a bit more difficult because in my notes are all text. There's no diagrams. Usually having one or two diagrams is easier for you to relate and understand this part. But it's fine. Let's continue. We're going to come back to this with hopefully with diagrams later. Yeah, let's not stop the flow. Let's continue now. Okay, last part here, then we'll complete step 3. 1 more minute. Bear with me. Okay, now we've completed step 3. Before we move to step 4, which is read the FAQ, let's do a very quick review. If you read this again, this is the reference. If you read this again, let's read this in 1 minute again. Then I'll ask you a question. All right, 1 minute is done. I'll ask you a question, very simple question. While you're reading this, do you feel that you understand more compared to, let's say, 30 minutes ago when you started reading step 2, when you see step 2 for the first time? Do you have the same feeling? Anyone?
No.
Who answered this question? Is it Eric?
Yeah.
Yes.
Yeah.
So my question is, when you read this 30 minutes ago and now you read it again, do you have better understanding now compared to 30 minutes ago?
Yeah, it makes it feel like it makes more sense.
Yes, yes. Good. Because I hear no just now, I was worried. Okay. So I think it's the same feeling that you got, Natalie, Junjie, and also Jaden, that it makes more sense now for this. Now we are only in step 3. Do remember that we have step 4, 5, 6, 7, and 8, and 9. And you're going to have a deeper understanding as we go along into the further steps, right? So let's do step 4 now. Step 4 is question and answer. Oops. Okay. Step 4 is frequent asked questions. Okay, just yeah, the whole thing is it's appear over here. So let's do 2 minutes. Start now. Oh yeah, sorry. Before I start, for Eric and also Natalie, for the benefit of both of you, how do you read this? It's similar to what we have done in step 3. When you read this, you ask yourself the first question: which drawer is this? 1, 2, 3, or 4, or 5? Then the second thing that you need to do is, while reading this and comparing to the reference, which is this part, is there any new information? If there's new information, intentionally pick it up and put it inside the drawer that you've created inside your brain, inside your mind, right? By now, your mind is having, or your brain is having more information in drawer number 1. If you, yeah. So, for example, this proton is positive charge, electron is negative charge. This is no longer a new information. Although it's not shown over here, but you already know it because you already read this in step 3 just now. And there are some new informations, or maybe there's no. If there's no new information, then it's good. That means you have already covered, right? You have covered near to 100% of what you need to know in drawer number 1, right? So obviously this is drawer number 1 because it's talking about the proton, the electrons, the neutrons, and talking about the electron transfer and such and such. Give you a hint. This is question 1. I have total 8 questions. Usually they are in sequence. So question number 2, maybe it's still in drawer 1, or maybe it moved to drawer 2. Very rarely, I will skip to drawer 5 for question number 2, just to give you a hint. But I need you to intentionally do this exercise to identify which drawer is these questions, right? So let's start again, start now for 2 minutes. 10 more seconds. Okay, done. So do you find any new informations or new understanding? Right? What's the difference between information and understanding? Information is, for example, positive charge and negative charge for proton and electrons. So it's a very obvious information that is new that you never read before. For example, obviously you have already read this in the previous step, step 3. Understanding is when you have the new informations and this allow you to understand certain concept or certain principle or certain new ideas. That is a higher level of information. So information is the first level, the first step. And if you can create a new understanding out of the new information that you identify, that is the second level, right? That is the second level. So if you are able to reach that new understanding and you're able to capture new understanding, that means you are already having a much better understanding for this particular drawer compared to, let's say, 1 hour ago. And if you realize this, as we move from step 4, 5, 6, and 7, the new information will be lesser, but the new understanding will be getting more and more, right? You'll see this later. Now, let's move on to question number 2, right? Same method, ask yourself which drawer, and if there is new understanding or new informations. Last 2 minutes, let's start now. Second. Done. Yinjie, which drawer is this?
Number 2.
What's the name?
Current, voltages, and resistance.
Okay, can you link it with the story? Which part in the story?
The CR7 EV car.
Yes. You know who is CR7?
Cristiano Ronaldo.
Okay, I hope everyone knows this, right? Everyone know this footballer, very famous footballer, right? Good. Let's do question 3 with the same techniques. Start now. Thirty seconds. Ten seconds. Okay, let me ask, which drawer is this? Jaden,
Yes.
which drawer?
This drawer is let's see. 2.
2, yes, drawer number 2, voltage, current, and resistance. Same story, Cristiano Ronaldo, right?
Yeah.
We did almost 1 hour, and we are still in step 4. Okay, let's speed up a bit more. We will do also 2 minutes. This is drawer number 3, circuits. Natalie, can you hear me now? I just saw your message.
Yeah.
Okay, good. 10 more seconds.
Uncle, I cannot see your screen.
You cannot see the screen?
No, I cannot.
Okay, you cannot. Let me share again. I'll just stop sharing. Okay, I started sharing again. Can everyone see the screen and hear me clearly? Eric, Yunjie, I see thumbs up. What about Jaden? What about Natalie? Okay. What about Jaden? You can hear and see me now? Okay, good. Okay. For the sake of Natalie, who got dropped just now, just do 1 more minute to read this. Whoever who read this, read it again and find whether there is new information or new understanding. This is drawer number 3, series and parallel, silly part. Okay, done. Question 5. Total, we have 8 questions, so we are almost there. Let's start 2 minutes. Ten more seconds. Okay, this is drawer number 3, the parallel part. Question 4 was the series. So let's go to question 6. Ask yourself which drawer and if there is new information. Start now. 10 seconds. Drawer number 4. Okay, drawer number 4, magnet. 2 more questions. Let's start now. Twenty seconds. All right, this is still drawer number 4. So obviously the last drawer is in drawer number 8, the last questions. Oh, it's a bit too long. Let's yeah. Yeah, let's start now. Later I will slow it down a little bit. Ten more seconds. Okay, so I think by now you know what is electromagnet. Electromagnet is something that when there is a current is flowing across the core like an iron, then it will create magnetic field. And why is this magnetic field important? These are the key applications. the maglev train, the electric motors, the relays. So this is the application of the electromagnet. This is in drawing number 5, electromagnetism, right, which is where our Elise got electrocuted, right, with the black face. Now, we completed step 4. If you do the same exercise and you read this now compared to 1 hour ago, now it makes much more sense. And we are just in step 4. We still have step 5. So imagine what type of understanding you will get when you complete step 9, right? And we only took slightly more than 1 hour. Okay, so let's do this. Step 5. Let's do the same practice, the same techniques. Tell me which drawer, tell yourself which drawer, and identify new information or new understanding. By now, you should have either very little new information that you're going to identify in step 5, and more of an understanding, new understanding that create the understanding of the drawers, of the chapters. Okay, let's do 1.1 and 1.2 for 1 minute. Okay, so Inje and Natalie, remember when we were in Azerbaijan, there was so much electric charges. When we were in the bus, we going out from the bus, and we touched each other accidentally. And now you can explain fairly well why these charges exist and how it was being created. Right? I hope it makes more sense now and it's getting more interesting. Let's do this in 1 minute. Okay, we finish draw number 1. Let's do drawer number 2. Okay, let's do here. 1 minute. Done. I think by now, most of the information that you read over here, you knew already, right? So that's why when I told you in step 1 or step 2, if you do not understand 100%, doesn't matter. Don't worry. Don't stress yourself. You're definitely going to understand this as we progress along. So this is where we are in now. We are still in step 5. We haven't finished the steps. So you're going to learn more and more and be more and more confident in this chapter. Step 5, let's continue. Let's do 2 minutes. Start now. If you finish reading, read it again. Try to get new informations from this, if there is. Okay, let's go to the next drawer. Drawer 3. I hope you can read these small words here. The font is a bit smaller. If not, let me know. Let's start now. 2 minutes. One more minute. Okay, We are almost done with our reading. Okay, let's do this in 1 minute. Okay, I think by now you should have a good idea about what's the difference between series and parallel circuits. Yeah, at least for now, you know parallel is the better one compared to series. And how is this current, voltage, and resistance is being calculated or is being in series and parallel circuits? Let's go to drawer number 4. Let's do this. And yeah, do this for 1 minute. Okay, this part, 4.3, 4.4. 1 minute starts now. Drawer number 4. All right. Now we are going to drawer number 5. Yeah, before we go to drawer number 5, I think if you read again on this keynotes, you have more information and more understanding compared to 1.5 hours ago, or even compared to 30 minutes ago, right? And next, I think you'll be worried, okay, like me, you'll be worried that after 2 days, yes, you remember all this, but after 2 days, you might forget most of them. Don't worry. We have another techniques to help you to remember this for a very long time. All right. Once you get these techniques, it's harder for you to forget than to remember. So remembering is easier than forgetting. Right? If you don't believe, you can ask Yunjie about her last chapter. It's very difficult for her to forget. All right, let's continue the flow. Drawer 5, 2 minutes. One more minute. Ten more seconds. Okay, we are done. Okay, this is the easier part. Let's read in 1 minute. Ten more seconds. Okay, done. So let's get 3 minutes break. Toilet or water break. Let's do it now. Start now. 1 more minute. Ten more seconds. Is everyone back now? Thumbs up. Okay, Yunjie is back. Eric is back. Jaden, Natalie, are you back? Natalie is back. Jaden, are you back? Yep. Okay, let's go to quiz. Quiz is not me giving you quiz yet. That's step 9. We are still in step 5. And after step 5, step 6 will be easier because you don't need to read anymore. But before we go there, just small part here. We have 10 quiz questions. How do we start? What is the technique of doing this? Number 1 is you read these questions and you identify which drawer. It's the same steps, right? But the second step is a bit different. The second step is once you identify which drawer, then you, without you reading the answers in your mind, you quickly form some answers based on some keywords. You do not need to form a very proper sentence for now, a proper sentence to answer these questions. But you can just form a very rough answers based on the understanding or the information in your first drawer, right? And the information in your first drawer is much more than this. This is just a reference. By now, it should be much more than this. For example, proton is negative, electron is proton is positive, electron is negative, and what is repulsion, what is attractions, same type and different type. Then how this electron is being transferred, and what is the impact, right? There is the electrostatic, yeah, those things, right? So those things supposed to be in your virtual drawer now. So when you read this question, this is question number 1. And then using, let's say, a few seconds or 1 minute, quickly form the answers in your mind. You don't need to read it out loud. You don't need to write it down. You just quickly form it in your mind. And once it's done, let's do that first. Let's do one by one. So in 1 minute, I need you to read the question, tell yourself which drawer, and then form some answers from your keywords and your drawers. Let's start now. Okay, I hope you identify that this is the first drawer. And by now you should have already formed some answers in your mind as your own, based on the understanding that you have in by following the steps from step 1 until step 5, right? Now, with that answers, you compare it with these answers. Is there any new information? Or is there any new understanding? All right, let's do 30 seconds. Okay, now do not worry too much about your answer is not exactly the same as the answer that is given. That's not the point. The point here is to train this skill, the skill of able to retrieve information in your brain drawer, which is inside your brain, fast, right? By doing the first step, the first step where you create your own answers without reading or without referring to the answer that's given yet, you are effectively training this skill. This skill is, what is this skill? This skill is the speed of you retrieving information in your brain drawer, in drawer number one, and put it out as a presentation, to present it as an answer. But of course, it's not in a very proper answer yet, because now we are still in a very early stage. Some keywords related to the questions to be able to explain the answers that you're going to put it inside, whether it's as a presentation format or whether it's to put it as write it down as to answer exam questions, right? So that is the skill that I want you to be. I want to train you using these techniques. Now let's continue. Let's do another practice on second questions. So what you need to do before reading the answer, I know it's very tempting to read the answer, but don't worry. We are not here to get 100%. We're here to train that skill. Read the questions, tell yourself which drawer, and then form an answer based on the drawer that you have in your mind now. 1 minute. Read question, which drawer, form answer. Read question, which drawer, form answer. Ten seconds. All right. So with the answer that you formed just now, compare it with this answer. Read these answers and compare it with yours. 30 seconds. Okay, done. We have 7 more questions. Especially Natalie and Eric, because this is the first time you go through these methods. Is it clear what we are trying to do and what you are trying to improve here? Natalie is clear. Eric, is it clear? If not, it's okay. Just tell me, because I think everyone knows everyone here. Okay, so let's go a bit quickly. Same thing. Now we'll do 30 seconds. Read question, which drawer, form answer. Okay, 30 seconds up. Now another, I'll give you 15 seconds. Just compare with these answers. Five more seconds. Done. Same drill. 30 seconds. Read question, withdrawal, form answer. Five more seconds. Okay, 15 seconds. Compare answers. Five seconds. Done. Question 5. Start now. 30 seconds. Read, withdrawal, answer. Five more seconds. Okay. Compare your answer with their answers. 15 seconds. Okay, I believe this question 5 is a new information or new knowledge. So intentionally pick it up and put it inside your drawer number 3. Next, read question, which drawer, form answer. Five more seconds. Done. 15 seconds, compare answers. Done. Question 7. Read question, withdrawal, form answer. Done. Compare your answer in 15 seconds. Next, read question, withdrawal, form answer. Ten seconds. Done. 15 seconds, compare answers. Done. Number 9, same drill. Question drawer answer. This is drawer 1, huh? Compare answers. Okay, last one. Question drawer answers. 30 seconds. Okay, compare answers. 15 seconds. Okay, the hardest part are all done. You no need to read anymore. Done. 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 So we are here. Step 6. Step 6 is easy. Step 6 is just watching a short video, about 5 minutes, I think. Let me get the video out.
我是马来西亚马来人。
我是新
Okay, this one.
Have you ever wondered what connects that?
Okay, do you hear the ladies or the man's talking?
Yeah.
Okay, everyone can hear, right? Okay, good. Now, how do I want you to watch this video? It's very simple. Do you remember your 5 drawers? By now, everyone should remember your 5 drawers because we already repeated this like 200 times. Now, I need you to intentionally, when you watch this video, link it with your drawer. Whether this is drawer 1, 2, 3, 4, or skip to 5, or skip back to 1, or skip back to 2. Right. Keep your brain active in this content. I don't want you to be distracted of thinking about your WhatsApp message that you need to reply, tomorrow what you want to eat, and etc. etc. So lock yourself, your brain, into focusing on which drawer is this in this content in this video. Okay, let's do it.
That little zap of static from your sweater to a massive train that floats above its tracks? Well, today we're going to pull back the curtain on the invisible forces that make it all happen. We're diving into the fundamental building blocks of our world, electricity and magnetism.
So let's kick things off with something that looks a whole lot like magic. If you just rub a balloon on your jumper,
Drawer
you can
1.
actually bend a stream of water without even touching it. And no, this isn't a camera trick. It's a huge clue to one of the most powerful forces in the entire universe.
So what is going on here? Really, what invisible force is strong enough to literally pull water sideways through the air? The answer is hiding inside every single atom.
Here's how we're going to break it all down. First, we'll start with the spark itself, what electric charge actually is. Then we'll figure out how to get it moving, and how to build roads for it to travel on. After that, we'll meet its mysterious twin, magnetism. Before, and this is the best part, we bring them together to see how they completely change the world.
All right, first up, electric charge.
Drawer 1.
This is really ground zero. It's the fundamental property that kicks off every single thing we think of as electric, from a tiny spark of static to a massive bolt of lightning.
Okay, so everything, you, me, the air we're breathing, is made of atoms. And inside those atoms are even smaller bits and pieces. For us, the ones that matter are protons, which have a positive charge, and electrons, which have a negative charge. Most of the time, they balance each other out perfectly, so objects are neutral. And these charges follow one simple, universal rule. Opposites attract, and like charges repel. So two positives will always push each other
Draw
away.
one.
Same for two negatives. But a positive and a negative, they are drawn together. That attraction, right there, is the engine behind everything we're about to explore.
So let's go back to our balloon. When you rub it on that jumper, you're not creating charge. You're moving it. You're literally scraping those little negative electrons off the jumper and onto the balloon. Now the balloon has way more electrons giving it a negative charge, and the jumper is left with a positive charge. And what do opposites do? They attract.
Static charge is pretty cool, yeah. But the real game changer, the thing that powers our entire modern life, is when we get those charges to move. That flow is what we harness for power. When those charges
Draw
start
two.
flowing in a steady stream through something like a wire, we call that an electric current. A good way to think about it is like a giant rope loop. The current is just how fast that rope is moving past you. We measure this flow in amperes, or just amps.
But, what's making the charges move in the first place? They need a push, right? That push is called potential difference, or what most of us just call voltage. In our
Draw
rope
two.
model, the voltage is the person who's actually pulling the rope, giving it the energy to get going.
And finally, there's always something trying to slow things down. That's resistance. It's basically a measure of how hard it is for the current to get through something. Back to our rope analogy, resistance is like someone else grabbing onto the rope, creating friction and making it harder to pull.
Okay, so we've got the push voltage and the flow. But to make them do any
Draw 3.
useful work, we have to give that current a complete path to travel on. We call these paths circuits, and they basically come in two main flavors.
First, you've got a series circuit. Think of this like a one-lane road. All the current has to flow through every single component, one after the other. There are no other options. Then you have a parallel circuit, which is more like a highway with multiple lanes, or branches. The current splits up and can take different paths.
You've definitely seen a series circuit in action if you've ever dealt with old, cheap Christmas lights. Remember those? Because it's all one single loop, if just one of those tiny bulbs burns out, it breaks the entire path. And poof, the whole string goes dark. Super frustrating.
So here's the crucial difference. In a series circuit, every bulb you add increases the total resistance, and all the bulbs get dimmer. But in a parallel circuit, every new bulb you add on a new branch actually decreases the total resistance of the circuit, letting more total current flow from the source. This is why you can plug in a toaster and your lights don't go out. Our whole world is built on parallel circuits.
Okay, let's switch gears for a second. For the longest time, people thought electricity
Draw 4.
was its own thing, but it has this mysterious, invisible partner that plays by very similar rules, magnetism. It shapes everything from your fridge magnets to the planet we live on. And here's the amazing part. We can actually see this invisible force at work. If you sprinkle tiny iron filings around a magnet, they'll snap into a pattern. They're tracing the lines of the magnetic field, showing us the shape and strength of this invisible region of force.
These patterns are like a map. The lines always point from the magnet's north pole to its south pole. And look here, see how the lines are all bunched up and crowded together at the ends? That's where the magnetic field is the strongest.
Now, this doesn't just apply to small magnets. Our entire planet acts like a gigantic bar magnet. It generates this massive magnetic field that surrounds us, and that's all a compass is doing. It's just a tiny magnet that's free to spin around and align itself with the Earth's giant field. And now, this is where it all comes together. This is the moment that changed absolutely everything. For centuries, we were wrong. Electricity and magnetism aren't separate forces at all. Turns out they are two sides of the very same coin. A moving electric charge creates a magnetic field, and a moving magnetic field creates an electric current. This connection is the engine of our modern world.
This discovery is incredible. When you run an electric current
Last draw 5.
through a wire, it creates a magnetic field around it. And if you coil that wire up, the field gets way, way stronger. That's an electromagnet. And its superpower? You can turn it on and off just by flipping a switch.
So what can you do with a magnet you can turn on and off? Well, you can do some truly mind-blowing things, like lifting an entire train right off its tracks. These maglev trains use powerful electromagnets to float, completely eliminating friction and allowing them to hit speeds faster than a Formula One car. And this very same principle is the beating heart of every single electric motor. You run a current through a coil, which turns it into a temporary magnet. You put that near a permanent magnet. The push and pull, the attraction and repulsion between those two magnetic fields creates a force that makes the coil spin. It's that simple, and it powers almost everything that moves in our lives. So just think about that journey. We started with the simple idea of opposite charges attracting, and we ended up with levitating trains and the spinning motors that run our civilization. By understanding how these two fundamental forces are connected, we've unlocked unbelievable power. It really just leaves you with one question, right? What are we going to build with it next?
All right. That is step number 6. So we move on to step number 7. Step number 7 is, where is it? I hope by now you have a much clearer understanding about this chapter. After step 7, it should be even better. Then step number 8 is to help you on how to not to forget it easily. Okay, let me just open step number 8. Step number 7.
Welcome back to the deep dive. Today we're
Okay,
doing.
wait. I'm going to pull out the keynotes over here. So I'm going to bold the part that the lady is talking about. Let's start now.
Doing a rapid exploration of electricity and magnetism, tracing the journey of charge from, that you get from a jumper, all the way to the forces that guide our planet.
It's a huge topic, but it all starts with one fundamental concept: electric charge.
Right. Positive and negative. And the basic rule is that opposites attract and likes repel.
Exactly. And that's what's behind static electricity.
Okay, let's unpack this. So that classic experiment, rubbing a balloon on your jumper, what is physically happening there? Are we creating charge?
No, not at all.
Yeah.
It's all about transfer. The negatively charged electrons are literally stripped from the wool jumper and they collect on the surface of the balloon.
So the balloon becomes negative and the jumper becomes positive.
Precisely. And now they have opposite charges, so they attract. The key thing here is that even these stationary charges create a force field around them, an electric field.
Okay, so a stationary charge has its field, but things get really interesting when those charges start to move. What happens then?
Then you get current. Current is simply the flow of charge, which we measure in amps.
Right.
Your phone charger might use half an amp, but something like a lightning strike, that's a massive instantaneous movement of electrons, can be over 1,000 amps.
And the push that gets it all moving, that comes from the battery.
Yes, that's the potential difference, or voltage. It's a measure of how much energy each bit of charge can transfer to, say, a light bulb.
I read in the source material that this directly inspired Mary Shelley's Frankenstein.
It did. Early experiments by scientists like Galvani using batteries to make muscles twitch were a huge cultural influence. This idea of electrical potential bringing things to life was, brand new and almost magical.
Of course, that flow isn't perfect. There's always some opposition.
There is, and we call that resistance. It's measured in ohms.
So if we stick with a water pipe analogy, current is the flow, voltage is the pressure.
Then resistance is how narrow the pipe is. It dictates how difficult it is for the current to pass through. And that relationship resistance is voltage divided by current is fundamental to every circuit.
Which brings us to how we build circuits. I think we all remember those old Christmas lights wired in series.
Ah, yes. The single loop.
One bulb breaks and the whole string just goes dark. It's infuriating.
Exactly. Because you've broken the one and only path for the current. That's why parallel circuits are so much better. They have multiple loops, multiple paths.
So if one branch fails, the others keep working.
Right. It's why your home is wired in parallel. You can turn off a light, but the refrigerator, on its own branch, stays on.
Okay, so we've covered moving charge current. But what's fascinating is that when charge moves, it doesn't just create flow, it creates something else entirely.
It creates a magnetic field. That's the deep connection.
And the Earth itself is basically a giant magnet, right?
A colossal bar magnet, yes. It generates a magnetic field that protects us, and of course helps with navigation.
The sources mentioned something I found amazing, that the magnetic poles actually flip.
They do. It's a very, very slow geological process. But the evidence in rocks is clear. About 500,000 years ago, your compass would have pointed south instead of north.
Wow. So, current creates magnetism. And that brings us to the electromagnet. My question is, why would we use one of those when permanent magnets exist and are cheaper?
One word, control. An electromagnet is basically a coil of wire. You can turn its magnetic field on and off instantly. You can make it stronger or weaker by changing the current.
Ah, I see. So for something like a maglev train, you need that control.
Absolutely. You're using powerful electromagnets to both levitate and propel the train. You can't do that with a simple permanent magnet.
And it's also a safety feature, right, in relays?
A critical one. You can use a tiny safe current to switch on an electromagnet, which then closes the switch in a separate, really high voltage circuit. Think of an X-ray machine.
A small current controlling a huge one.
Exactly. And that same principle. A current-carrying coil interacting with a magnetic field to create movement. That's how every simple electric motor works.
So what does this all mean? We've gone from a static shock all the way to the engine of modern technology.
It means that electricity and magnetism aren't really separate forces at all. They're two sides of the same coin. The electromagnetic force.
Okay, here's a final thought. Scientists believe the Earth's magnetic field is generated by moving charges deep in its core, like a giant natural electromagnet. So what everyday device in your home is essentially mimicking that massive planetary process on a microscopic scale?
Okay, done. Step 8 is done. Step 7 is done. We're going to step 8. Step 8 is this very ugly picture. Right? So in order for us to remember not only the drawer, but the story inside the drawer to help us to retrieve information inside each drawer easier, I created a very illogical or silly stories. And my drawing is not good, so just bear with me. If the story makes sense to you, not make sense in terms of the sense of the storyline, but makes sense in terms of helping you to remember the content of the story better, then you can use the story. If not, you can create your own story. You can also draw your own pictures, which definitely better than my pictures. So let me explain quickly. I just will take maybe 5-10 minutes maximum per drawer. What is the story? If you realize in this bracket that I told you to ignore initially, now is the time for you to focus on. Right. So this is actually the story per drawer. So we have 5 drawers, then we have 5 stories. So you can see there are 5 pictures or 5 stories in the 5 pictures. So what is this? Number 1, electric charge. Electric charge. The story is a pen couple attracted and fight with each other. So what is pen? Pen is representing proton, electron, and neutrons. Right? And why is it couple? Because boys and girls sometimes they fight and sometimes they attract to each other. So this is to represent the repulsive and attractions, right? So this is the first story. Second story for second drawer, which is the current, voltage, and resistance. I or somebody, or you can use Elise, or you can use Jaden, okay, pushes a vampire. So this Jaden push vampire, and the vampire is like bite, right? Bite back. So that represents the push, represent the voltage, right? The voltage is the push that caused the charges to move around a circuit. So that push, the keywords will trigger you to remember voltage, right? And the vampire, the V, is also representing the voltage. The empire is representing the current, the amperes, right? Sounds similar. So this will help you to remember the current, which is related to the amperes, which is the unit of it. And ohm. Ohm is what? Ohm is bite back like the sound of So that's resistance. So this will help us to remember resistance. So in this drawer, there is current, there is voltage, there is resistance, right? Then the third drawer, series and parallel circuits. So what I do here is I use Eric's mummy name because I cannot find somebody who the name start with S is to be related over here in this story easily to relate to the students that the four of you here. Okay, easier. So I use Sarah. Sarah says no. Papa flows faster. Right. So this is Sarah says no. Then Papa flow faster. What does it mean? Sarah is representing series circuits. Papa representing parallel circuits. Says no. No means resistant. So in series, the more resistance that you put into the flow into the circuits, the resistance increase. So series is very sensitive towards resistance. The more resistance you put, it increases. It's opposite of parallel. Parallel, the more resistance you put in it, the less resistant it is. Right. And what does it mean by flow faster? Flow faster is it has a bigger current. The total current increases as you put more branches in it. Right. So parallel is related to current because current is flow. Right. You remember the current is talking about the charge flowing per second. So this is my story. Right. Again, if the story doesn't make sense for you or it's harder, you have another story that is easier for you to remember the information, please do it and create your own story. Then drawer number 4. Drawer number 4 is Iron Man fly from North Pole to South Pole. Right. So there is this Earth from North Pole to South Pole. This Iron Man is flying from North to South. What does it mean? It means Earth will have a North and South Pole. And you need iron to be able to create that magnetic field, right? And then you have iron filling or plotting compasses, right? So the iron is representing, the Iron Man is representing the iron filling, which is the method of verifying the magnetic field, right? Then electromagnetism, the last one. Electromagnetism is coil Iron Man fly fast. So Iron Man, you know the Iron Man, and now we call it with the wires over his body. So this is, if you can see, this is like a spring. We call it up with his on his body, and this is Iron Man with his hand and leg. He's flying very fast. Right? What does it mean? It means that the more number of loops of the coil, the stronger electromagnet, and the faster the current flow, the stronger the magnetic field, the electromagnet. And the iron core, which is the Iron Man. So the core of this need to be an iron to be able to form it as an electromagnet. Then and that is the story, right? So that is basically step 8. Step 8. So imagine that you follow my story and you are now walking into your exam hall, right? And obviously you cannot bring your book into your exam hall. And obviously you will not be able to remember all these words by words into exam hall. But it's very easy for you to draw this out before you go to before you start answering your exam questions. This one, if you train yourself good enough, maybe you can draw this in less than 1 minute, right? So take 1 minute out from your exam time, a total of, let's say, 2 hours, 1 minute, you draw this out, and then you'll be able to use this as an anchoring point for you to remember the information that is behind each drawers, right? Because our brain, human brain, designed in a way that we need to have anchoring point. So this is acting like an anchoring point. The drawer is acting as an anchoring point. The story of the drawer is acting as an anchoring point, right? For you to remember the information or the answer to be able to answer the questions. So now let's go to step 9. Step 9 is basically to test your understanding about this chapter. So what I do is I'm going to upload. Wait. I'm going to why it's not moving? Okay. I'm going to upload the files related to this chapter. Okay, let me open this this PDF file. This PDF file is one of the books that I found in the internet that is related to this chapter, which is electricity and magnetism. This is GCSE chapter. So if we go through it quickly, total there are 22 pages. If we go through it quickly, let's see whether the content is relevant, is in the same sequence as what we have learned just now. So charging up. So this is first drawer. So it's talking about the positive, negative, and the neutrons as a neutral. Then it's talking about the experiment. Then this is the electromagnetic field. Is it? Yeah, electric field. This is electric field. Then it talks about the circuits and the current. So you talk about the current first. Then talk about how you measure the current, ammeter. Then talk about the circuit symbol that that you can use. These how to draw the cell, battery. Of course, this is not that in our notes, because our notes are all in text. Then it's also talk about the voltage, which is the potential difference. Okay, then talk about the resistance. So this is drawer number 2, right? Then drawer number 3, charging the subject. Right, this is talking about how do you charge the subject. Okay, right. Then is the series and parallel. This is the drawer number 3, the circuits. Right, it's talking about the difference between the series and parallel circuits. Then the next one is the drawer number 4, magnet. Talking about the earth magnet. Right, and also the magnetic field. Right, then the drawer number 5 is the electromagnetism. Right, and how do you use electromagnet, the maglev, and that's it. And then there's a summary. So pretty much we have covered, I would say 90 to 100% of this book or this chapter. So now let's go to, where is it? Where was the, yeah, here. So I uploaded the PDF file just now. Let's ask me 10 MCQ 1 by 1 without answer. Okay. So imagine that you are now in the exam hall, and what you have done is you draw this picture in front of you. What I need you to do is, when you read the questions, tell me which drawer and tell me the answer. All right, can we do that? In another maybe less than 10 minutes, then we are done. Okay, just bear with me for another 10 minutes. So let's start with Yunjie. Yunjie, can you read the questions and tell me which drawer?
When you rub a balloon on your jumper, what happens to the charges?
Which drawer is this?
Number 2.
Number 2. Everyone agrees that it is number 2. Number 2. Eric, you're typing something. Okay, you have to go. Okay. See you. Bye-bye. Right. Okay, which answer is this?
B.
B? Boy?
Yeah. Yeah.
Anyone? Yeah. Anyone object this? 5 seconds. 1, 2, 3, 4, 5. Okay, so B. I think this is not drawer number 2. This is drawer number 1 because it's electric charges. Drawer number 2 is about current, voltage, and resistance. Let's see whether the answer is correct. All right. Let's go to question number 2. Jaden, which drawer and which answer?
Amps. Atmosphere. C.
Louder.
C.
Which drawer?
Drawer number 2.
Yes, this is drawer number 2. It's talking about the current, right? So you can see drawer number 2, you have current, voltage, and resistance. Okay, Natalie, which drawer? Yes, which answer? Natalie, which answer? Which instrument is used to measure potential difference in a circuit?
B. B.
B. Okay, I can hear you now. Okay, number 4. Eric, are you still here?
Yeah.
Okay, we are almost done. If you can just bear for another 5 minutes.
Okay.
Can you read the question and which answer? Which drawer?
This is drawer 2.
Yes. Do you still remember the formula?
Hmm?
Do you still remember the
Pardon?
formula to get you this answer? What's the answer?
Yeah. Answer is resistance equals potential difference divided by. Wait, what?
Yes.
Wait a minute. Oh, divided by current.
Yes. What is the answer?
The answer would be 12 ohms.
It's C. Okay. Ohms.
Yep.
Yes. Anyone object? 3 seconds. 1, 2, 3. No one object. All right. Exactly.
Oh.
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 Yes. Even I got it wrong. Yes. But you're right. If
my
you
brain's
do
kind
it,
of broken.
no, even my brain's broken also. I thought it was 12. All right. It is 30. Yes, you're right. Yes. We are just too confident in ourselves. Okay. Question number 5.
Brain was broken.
Let's do it. Eric, you do it.
Oh, okay. What does it mean by it the current it decreases?
B. Okay, anyone
Yes,
object?
B.
1, 2, 3, no object. Let's see. Okay, Yinjie, number 6.
Which? I don't know.
Okay, anyone want to answer? Right. Let's do it one by one. Parallel is the better circuits compared to the series, right? Let's start with C. If one bulb breaks, all bulbs goes out. This is series. This is not parallel. So this is out. The resistance increases when more branches are added. This is also series. This is the Sarah says no, because Sarah is always resisting. So series is
it
always
D?
resisting. Any one object? Let's say. Right, good. Question number 7. Jaden. Jaden. Which drawer? Which answer? Jaden.
Sorry. The drawer is 3 and the answer is D.
Again, I cannot hear you. It's too. Can you speak louder?
The drawer is 3 and the answer is D.
The answer is D. Anyone object? Everyone agrees? Eric, do you agree? Natalie, yes, you have something to say.
It's C.
C. Resistance. This is drawer number 2. Drawer number 2 and ohm. Ohm is the resistance unit. Right? So it's C. Yes, Yunjian, you don't think so. You think C? Right. Number 8. Which of the following materials is magnetic materials? Let's Natalie. Oh, let's Eric, let's do it.
C.
C, the Iron Man. Remember the Iron Man? Right, this is drawer number 4. What happened to an electromagnet when the current is switched off? Drawer number 5. Let's try Natalie.
C.
See, anyone object? No one? Let's try. Last question. In an electric motor, what causes the coil to spin? Let's see who wants to answer this before I point to somebody. Okay, Eric. Which drawer, which answer?
This is drawer. This is drawer 5, I think. Wait, no.
Yes, you're right.
Drawer 5. And then it is interaction between the magnetic field and the. Wait, no, not that one, not that one. Wait a minute. Yeah, it is C. It's C, I think.
It is C. Anyone object? Let's see. Why did it not come? Yep. Okay, total score. He already gave it to us. 9 out of 10. I think some of you got 8 out of 10. Some of you got 9 out of 10. Everyone got this wrong. I think it's a careless mistake. The one from Eric, this one. Even I overlook it. Right. So this shows that you have a good understanding, right, of the chapter already. And how long does it take? What's the time now? 11:48. 11:48. 11:48. So we took 2 hours and 40 minutes. 2 hours, 40 minutes. If we do it fast, we can do it in less than 2 hours. But because there are 2 students that are new over here, so we take a bit of a longer time. Now, let me emphasize step 8 again. I think step 8 is important, but it's not emphasized enough. Because you have already done this 2 hours exercise with step 1 until step 7, your memory is still very, very fresh. So even if you start doing exam questions or any quiz question, you are still quite confident in answering all the questions correctly. But if you started to do this, after 2 weeks or longer, chances of you remembering all this is lesser, right? So this is where the story plays a role here. This is where the story plays a role here, because the human brain is designed in a way that we need to anchor on something. When there is something to anchor, then we are able to remember this easier. And when that things that is you're anchoring is having emotion in it, it's easier for you to remember. So this is just an example. This is from me. You can have your own. You have your own story, right? Yes, Yunjie, you need to go.
I forgot what the R was in CR7.
What's the R was?
Yeah.
Yes, the
Oh
R is
wait, it's
resistance.
resistance. Never mind.
Right, excellent. Okay, good. Right. So once you remember the story, like what Yunjie was asking, Elise, charged Cristiano Ronaldo expensive EV car with magnet and got electrocuted. So that is to help you to remember the drawers. And then the content of the drawer is these stories. You can create your own stories, right? These stories maybe is not suitable for you, but for me, this is how I created it. It's helping me to remember this informations easier, right? All these informations easier. Once I remember all this information easier, the information that I collected while I'm reading this step 3 until step 7 will come in, it will flow in easily, right? So what you need to do is, if you believe in this method, you need to keep practicing. You need to keep practicing on these stories. Worst case scenario, if you've forgotten everything, you just need another 2 hours to start from step 1 until step 8. Right, 2 hours is not something. It's not a very long time. You could have easily watch your YouTube or TikTok and spend that 2 hours already, right? So that 2 hours will help you to remember and understand exactly as what you understand today now on this chapter, right? So one more point. Imagine now you are able to have a very good understanding about this chapter in 2 hours. How many chapters do you think you have in your year 8 science? Maybe 10 or maybe less than 10. Let's say 10. Worst case scenario 10. 10 times 2 is 20 hours. How long is 20 hours? It's less than 1 day. It's less than 1 day. Obviously, I'm not expecting you to spend 20 hours straight per day to finish off your science, which your teacher would easily take 1 year to complete. You can break it up into a few days or 1 week. What does it mean? It means that you have more time for your TikTok, for your YouTube. Am I right? So you can happily tell, you can be more confident in getting your science, understand your science well, but at the same time, you have more time to do something else. Okay? I think that's it. Thank you. Bye-bye.
Thank you.
Thank you. Bye bye.
Bye.
Bye-bye.